Hello, my name is Adam Harsha, and I'd like to present to you my Autoencoder-backed movie recommender. So here I'm using Autoencoder to create a movie recommendation system. Um, so Autoencoder, what is Autoencoder? It is self-learning neural network that consists of an encoder, decoder, and then the latent space or the coding in between. In the class, we have learned or used autoencoder for dimensionality reduction, transliterating digits, as well as denoising stranded images. Those are some uses that we have witnessed what autoencoder is for. And then the question is, could it be used to recommend us what movies to watch next? Sure, why not? And that's exactly what we are um, doing in this experiment. In our experiment, we will have four different models, model 1, model 2, model 3, and model 4. Our model starts with input, which then gets into the first layer from top to bottom. And as you can see here, half of our models have 7 layers, while the others have just 6 layers. Those with 6 layers, like Model 3 and Model 4, have only dropout layer after the latent space, which is colored darker than the other layers in this diagram. So these are all the latent space I'm talking about. Our neurons are mostly activated with CellU, so there are so many cell U here, and majority of neurons activated with cell U, except the ones in model 1 where there's a layer on which the neurons are activated with sigmoid. And this is quite unusual since none of our model is used for classification. So why do we do this? We do this essentially because we want to kind of get a yes or no fit right from the start for some of the model. And I think it's interesting to see whether doing so would make the model performs better or not than the other models. Moving on, let's talk a little bit about our data. So our data is downloaded from Movie Lens, which is a work by Group Lens research group from the University of Minnesota, Twin Cities. It has a rating data frame, which is core to our experiment. It contains more than 32 billion entries. It has user ID, movie ID, and the rating. The rating is real value from 0.5 to 5.0 maximum. And then there is the movie data frame, which has thousands of movies in it. As you can see here, it has the movie ID, the title, and the genre. Um, and then we then do pivoting to arrive into an M times N interaction matrix where the rows will represent users and each column represent a movie. At this point, our data is scaled, so every rating is now between 0 and 1 instead of 0.5 to 5.0. And now let's talk about the result of our training. I'll show model 2, 3, and 4 first because they look pretty much the same, honestly. And here we can see cell activation function is in full swing. Those lines look very well regularized. Model 3 also has kind of similar graph, and so does Model 4. But if you notice, the gap from Model 2 to Model 4 keeps getting smaller, even from the beginning. So this is Model 4, Model 3, and then Model 2. The gap is getting smaller and smaller. Bam! Now Model 1. The gap is so huge from the start. Could be because the sigmoid Well, very likely. The graph in a way looks like that region of sigmoid from 0 to 1, like around here. It's kind of reminding us about how the graph of sigmoid looks like between 0 and 1, kind of. We can say that model 1 perhaps has the most learning, considering how initially it has the largest R2 gap than any other models we have seen. Um, so yeah, but how does it perform in practice? So for this experiment, let's focus on user with ID number 10 for now. And these are movies that this user um, rated top, basically. These are top 100 movies most favorably rated by this user. So this user likes action. You can see like Godfather here, drama and comedy like Fair and Loving in Las Vegas, horror like The Exorcist, sci-fi like Star Wars, with some taste of animated movies, and romance was once in a while, as well as fantasy like Narnia. And the Model One um actually is very good. I was surprised. It's in fact surprising for me, maybe, that the user has never watched Good Will Hunting and A Beautiful Mind, or maybe he hasn't read them just yet. But regardless, I'm very certain that he would enjoy watching those movies, um, especially if he hasn't yet. And here we see that actually a lot of those movies are from kind of the same years. So these users actually watch a lot of movies from the 60s, 70s, 80s, 90s, and so forth compared to the later ones. So, and this model correctly kind of predicted, given a recommendation of movies from around those years, with few ones or one or two from um, newer later release, like Spirited Away and A Beautiful Mind, for example. Yeah, this is honestly solid recommendation. I would really love watch to watch Good Will Hunting and Monty Python if I were him, or Beautiful Mind. Yeah, basically every one of them. Like Fargo is a thriller a movie. So coming next is Model 2. Unlike Model 1, actually, which in top 50, there's only one horror movie recommended. In Model 2, we got some, such as this Mandy Lane. Interesting. And movies are still kind of related. Starship Troopers, because the user watch a lot of Star Wars, to the point that there's no Star Wars left that he hasn't watched. So Starship Troopers may be kind of related. The Patriot, Wally, cartoon, the cartoon, the romance, adventure kind of cartoon. El Cantante reminding us of the Godfather. And then the Model 3, it also offers broader category, yet we can still sense the recommended movies are still of the same tune. In this model, A Beautiful Mind actually comes first. This is a movie from 2001 actually. And in Model 1, again circling back to Model 1, all the top 7 are movies from before the year 2000. But in Model 2 or Model 3, the year kind of doesn't get accounted for, not that much at least. So it's solid. Box trolls are fun, adventurous, the Incredibles, The Condemned, 10 people will fight, 10 people will die. You get to watch. Sounds like the kind of movies that American Psycho, thriller. Yeah, it's beautiful recommendation, like really solid ones. And then mm, Model 4. At this point, I think it's hard to decide which model performs better. I could at the end comes it could comes from taste and preference. I feel that Model 4 actually have the best mix overall of both new and older movies that should suit the user well. We can argue that maybe Model 1 is closer to the ground truth in terms of the release year, yet it is hard to say that Model 1 is the best. Maybe it's better to use multiple models, in fact. Movies recommended by Model 1 and Model 4 can be placed first or among the first, whereby Model 2 and Model 3 offer mm, alternative selection. Although those movies can be somewhat loose in terms of the years, but who cares if user 10 prefers newer movies, then really he wouldn't really like Model Y, would he? So yeah, it's kind of tricky to assess which model is the best or the better one, because at the end it can just um a personal matters, very highly subjective, that is. But the point is, it's relatively easy to build those models and fine tune them. We just need to create the autoencoder and then train them on the on the movie lens data set, and tada, we have a recommendation system without the need to know advanced statistical prowess. Just deep learning knowledge is enough. But yeah, so let's study their pros and cons more closely. The pros is that it's, as we have said before, it's very fast to build recommendation system even within a day or two. In fact, we did this in a week, um, less. But yeah, the next point is that we can skip statistical theories such as market basket analysis to arrive at this awesome, wonderful recommendation system. And it's kind of easy to tune the model behavior. Easy enough, at least, compared to, for example, if we have to use LLMs to build such a system. And the cons is that it can be hard to understand why it works the way it is. And then it also needs training data. It cannot start empty-handed. So if we don't have training data, we can we really cannot do this. And then we will also need to retrain once for new movies, once we have new movies and rating data. So yeah, that is our final project about using autoencoder for movie recommendation. Thank you very much for the wonderful class.